So again, this one here, the standard position angle is given as a position, location with x and y coordinates. So I know exactly which quadrant it's in. It's -2, -8. So maybe somewhere around there. So -2, -8. -2, -8 represents the standard position, the coordinate position of that point. Okay, and we want to find the exact values for sine, cos, tan. Now, since we know the position, we only give one answer for this. Okay, we only have to consider one answer because we know the location of that point, and we don't have to worry about, being in quadrant 2 and 3 or 3 and 4. So when I solve for sine, cos, tan, I'm just going to use Pythagoras. I'm going to end up with square root 68. And again, since I have two sides of the right triangle, I'll give my answer in exact values. And cosine theta is equal to -2 over square root 68. Sine theta is equal to -8 over square root 68. And tan theta is going to be the slope. That's positive slope. It's -8 over -2, or slope of +4. Now, solving for the angle, I can use any one of these. I'm just going to use cosine. Okay, so I'm going to use the inverse cosine. Okay, the input is the ratio. The output will be the angle. Okay, so I have to always remember I'm inputting the right type of information into my cos. I never do cosine of the ratio. I do arc cos of the ratio, and that gives me an output of the angle. And my calculator angle, I'm going to call theta 1. So when I give theta 1, I do second cos of -2 divided by square root 68. And I get 104.04 degrees. So that's equal to 104.04 degrees. Okay, so looking at that angle, I have to make sure that I'm in the right quadrant, because remember, there's always two possibilities. There's always a theta 1 and a theta 2 involved when we undo sine, cos, tan. And 104.04 degrees is in the wrong quadrant. It's over here. It's in quadrant 2. It's that position right there. That's 104.04 degrees. That's not the one I want. That means then I must need theta 2. And my calculator is not going to give me theta 2, but however, I can use the symmetry of this circle to give me theta 2. Now, depending on sine, or if sine, cos, or tan, we have different symmetries. So in this case here, I have folding symmetry again across the x-axis. For sine, it's going to be folding across the y-axis, and for tan, it's going to be rotation on the opposite side of the circle. But here, using that, I'm just going to subtract from 360 degrees. I'm going to subtract theta 1. Okay, and I'm going to get an angle in standard position. The positive version of this is going to be 360 minus theta 1. I'm going to end up with 255.96 degrees. And that is in the right quadrant. So 255.96 degrees is in quadrant 3, and that's the angle that I want. Okay, that is my 255.96 locates the correct position of -2, -8. Okay, so that's my standard position angle that I want. So this, I have to ignore theta 1 because I know the quadrant. I only give one solution for this because the quadrant is known. And I have to decide whether I'm dealing with theta 1 or theta 2. And based on the positioning, we can tell by the quadrants.